We continue in Chapter 17 with more SAS graph procedures, or two more here, and then we'll also add on some information from Chapter 18, and that should be the end of the videos for this semester. In SAS graph, we do have three-dimensional plotting capability. This is different than what I had in statistical graphics. There are some advanced procedures in the statistical graphics procedures that were first introduced in Chapter 16 that also do some three-dimensional capability. We just didn't include those. There was quite a bit of new syntax to learn there as it was. Here we can get a 3D image pretty quickly, and having introduced new colors in the previous SAS graph video, we don't have to add that. It's the same way we get colors. We just have a little different way of specifying patterns, and of course then how do we get what is this 3D element here. So we're just going to have the one 3D procedure, proc G3D, and so there are two different kinds of statements for proc G3D. There's a scatter statement and there's a plot statement. For the plot statement you need a lot of data. For the scatter statement you don't. And so the scatter is just going to give us a three-dimensional depiction. So we've been working with vertical by horizontal. Well, now that's going to kind of be the base of our graph, and then vertically on the page will be what SAS calls the Z variable. And then we can have some different options. And so on the scatter statement we can change colors, we can change put in commands that modify the axes in either direction. We don't have quite as much flexibility as I would like, and we'll talk about that as we go here. On the scatter statements you can specify a color where the color has to be in quotation marks, and there's also a color variable. And so the color equals variable, that is, you can set up another variable, say a C variable, and it takes on values that are colors you'd like in the graph, and so then it uses that. If it's not in quotation marks, it uses that C variable, and so that it would put in different colors in a three-dimensional scatter plot. But if you use the color option and you specify the color in quotation marks, that's the only color you're going to have. So if you want multiple colors, you need a color variable. By default, G3D generates a needle that draws down from the point in 3 space down to the XY plane. We can look at different shapes for plotting symbols, and this is different than I said it exactly. I said symbol. Shape is a three-dimensional item, and so these are different than the options we had for symbol. So I do need to be careful there. Again, you have to put that shape in quotation marks. It has a default shape that it chooses, and we can look at what those are. Also, similar to the color, if you wanted to have multiple colors, you needed a color variable. You can also select multiple shapes if you have a shape variable. Annotate, rotate, and tilt are some other appearance options. So rotate and tilt, they tip the graph kind of towards you in a three-dimensional setting or away from you, and rotate, I don't go into those there. The annotate process is actually you probably are better taking the image and pulling it into another editor to add text to, rather than this annotate option here. So I don't go into those. Those are once you become very competent at the remaining things. You can modify the different axes, so you can specify the color of the axes and any tick marks or grid lines, colors of the text on the axes, and then if you want it to draw reference lines in the background, it's a grid. And then you can specify the number of tick marks on the x-axis and the y-axis. It defaults at 4. We don't have a great lot of control here like we did with the axis statements whenever we were looking at Gplot procedures and Gchart procedures. Zmax has a little bit, or Z-tick number and Zmax, we get a little more flexibility with the Z-axis than we do with the X and Y axes, because you can specify a starting value and a top value, but we don't have those options in the X and Y axes. The axis statements we were using previously do not work in this current version of SAS. I'm hopeful that soon that's remedied, and there are perhaps some platforms where the axis statements do work with it, but it's not here for us, unfortunately. So we're going to look first at just kind of what a default scatter plot looks like. We're using the BEEF3 data, the permanent SAS data set. We're going to use this for heifers only from producer 3. Remember, producer 3 had both steers and heifers in the list, and so we're just going to restrict that. Part of the reason I'm doing that is to reduce the number of points so that we can see what's going on in the graph, and I'll talk a little bit about why that's an issue whenever we see the image. So this is our objective 17.10, our default G3D scatter plot. So in proc G3D, we restricted it. We used a scatter statement, and so we have an a y by x equals, and then the z-axis is going to be the carcass weight, and then we're going to use black pyramid shapes. And so that when we run this, I'm going to reset all the options so that if I have any previous active graphic font or graphics colors, all that's been reset. Again, that took a little bit longer to run because of the recording software I'm using to produce this video on this machine. So this is our default. So we had in our graph, let's toggle back a second, it was y by x. So average daily gain was the y-axis, and that's the one down front here. The x-axis is the one that's going back here, and you'll notice they have 4 tick marks as the default. The black pyramid, so the pyramid is the symbol that's drawn, it's from the 3D point, and we have these what were referred to as needles drawing down from the point to the XY plane, and then this is the Z-axis here for carcass weight. And so it sets the lowest observation for the XYZ value. The lowest Z value establishes this minimum Z at 704, and so that's why this one pyramid is like sitting on that XY plane, and so that there are things we can do to change color and give a little more three-dimensional perspective. However, while we're here, what we may look at this and say, look, we can keep this, and one option we can show is the no needle option, so you know what that does. So the default was it produced that needle, and so these are just kind of pyramids floating in 3 space, if you will. So we don't see kind of the three-dimensional effect there as well, in my opinion. You may see things a little bit differently. We could experiment with color for these plotting symbols as well, and so I can do that here in the video where I couldn't in the book. So if we come back to the program and say change the color to blue, keep them at pyramids and no needle, if you just change one option at a time, then you can see the effect of it. And so you can get you can add color, of course. Then as some of the options indicated, you can change the color of the axes too, so that if you were to work in blues or a medium blue or some other color for the axes, you can accomplish that as well. So if we'd like to reset this bottom 704 here and maybe put some values in here that typically we think of things in multiples of 5, 25, or 50, those kinds of things. So rather than have our axis start at 704, let's have that go from 700, and then we look at a maximum here. It's above this 835 here, so we can put, and these are the heifers, and so let's change that up a little bit. We'll add both the steers and the heifers to the data set, but put each on a different plot in the next objective. So in this objective, in order to look at a plot for the heifers and then a second plot for the steers, I need to perform the G3D procedure by sex for producer 3. So notice you can do where and by statements in the same procedure. But I must sort the data first here by sex to be able to do that. And then I can look at the same scatter statement. I'm changing my shape to a pillar. There are no needles. A no needle option isn't meaningful for a pillar, and I'm going to use gray. That matches what we're doing in the textbook to run this. And I change this z-axis to go from 700 to 1000, and we'll look at the effects of this. Okay, this is the second image. It says sex equals steer, and so the pillar, you can see then we have these cylindrical shapes then from the point down to the plane. And so when you choose a pillar, it is its own, the very shape we've chosen is its own, provides a needle. And so we also have that new axis here for Z. That makes a lot of sense here. And if we scroll up for heifers, notice we have the shorter bars here. We'd seen before with some of the weights and such that we knew the heifers were smaller, and here we see an example of that on the y-axis and the x-axis here. We didn't make any changes to those at this point. The other and the most notable thing here is I've kind of got this back wall in here, and so it drew a line for each one of these values on the tick marks. That to me helps with my 3D perspective, and that's achieved by this grid option, where you saw the auto ref and clip ref options before in Gplot. Grid does that here in the G3D. I can choose minimum and maximum values for the z-axis, and to do this, this is really you do this in multiple settings. You have to see what works for each of them, and so that in order to arrive at 1000 as a maximum in there, so you have to run it a few times, and because if you make it too short, it will crop those or delete that data point or won't show it. Now whenever you do, one of the reasons I don't have them both on the same plot is because that if there's an overstrike here, it only prints one of them, and so you don't know how many are there. And so for G3D, I tend to, for a G3D scatter statement, I look for typically smaller amounts of data to be able to represent that on one set of axes well. G3D is also used to produce surfaces, and these can look really cool, but requires a lot of data to generate a surface well. So those previous observed data we have in BEEF3, even though there are a few hundred data points, that's not enough really to give us a surface. And so we'll explain this here first. Whenever you want to look at a surface, there are two things here. Within the G3D procedure, the statement is plot, not scatter. And so that if you're going to use a plot, that's going to generate a three-dimensional surface. You can look at the G3 grid before that, and so what this does is it puts things in a compatible order, and you use the same, your grid statement is the same as the plot request you make in the plot statement. So that way it assembles things in the right order so that the G3D procedure can generate an appropriate surface for this. You can change the colors of your graphs. You're going to have a top surface and a bottom surface. You may be able to see only one or maybe both, and you have those controls. You can choose sidewalls. You can choose how you want lines to depict the surface. The one for us is the x type equals 0 is not available to us, so that's for Java and ActiveX file types. So we're going to look at XY types 1, 2, and 3, and that in the default for what many of the options we see is for x equals 3. Objective 1712 asks us to plot the surface equation for this three-dimensional graph. We have here a cubic equation in x, so it's x cubed plus 3xy squared plus 3y squared minus 15x. So you have to generate the points on this surface to be plotted, and so that x, y, z in that order. And so we can go back to the nested do loops to do this. And this is again is kind of by inspection. You can run this and set your lowest x values and your lowest y values and figure out what your largest are going to be. And so here I did happen to choose something that where the behavior is kind of about 0, and so that I didn't have to go out really far from 0. But in practice you have to kind of pick an x and y starting value and a stopping value and see if you capture the curvature you're looking for. So within the nested do loops, I compute the z, so I can either write this as this is x cubed plus 3 times x times y plus 3y squared minus 15x. So that's what I'm looking for here. We also know we could have done this as x double star 3. The double star is exponentiation, and this could have been 3 times x double times y double star 2, and this is 3, could have been y double star 2 here as well. So it goes through all of this. We use the output statement to write down a new observation each time, and then we want to make sure and run this through grid. Now if you switch your axes to x and y, the reverse orders there here in this particular thing, you do need to run G3 grid again. So I chose the color, the gray to be the color of the top surface and black to be the color of the bottom surface. This I'm calling view 1. In the second one I'm reversing the x and y, and that also has a similar effect as some of the rotate option we had before. And so this, first of all, let's run this. Run the data set first. And we have 1071 observations. And okay, so we have a lot of data here. And then we bring that into G3 grid and the G3D. When I switch x and y, I regrid that, and then I produce the second view. So first the view 1, y is in the front, x moving back, and I didn't have any axis point selections. I let SAS do all of that first. So the gray is on the top of this surface, and so I kind of see this three-dimensional surface curving away from me, and it curls up back here at the end, and I see a lot of the bottom part of this surface. So if you want to think about it, if you wanted to turn this 90 degrees, that would be the effect of switching the x and y. So I did that in the next picture. And so I have there, so previously it was like I was looking in from this direction on the right. Now I've got a different perspective. Also, I changed the top surface. In the first one, I see a gridded surface here, both in the x and the y direction. That is the xy type equals 3. And here I have it only in one direction. Now we have to be really careful here. It's labeled X, but it's really the y-axis as SAS sees it, and this is what SAS calls the x-axis. And so for the second view, I have xy type equals 2, so that means it's parallel to the y surface, or the y-axis, so that's why we see these lines here. I have the grid in the background to give it that three-dimensional effect. After I ran this and kind of saw in the first one what range of values my z values went from, I chose some values from -25 to +25. You can choose the color for your top surface. So here I just chose gray and black to work with the book publication, but I can change those to any other colors I like. So if I put the top color as blue and the bottom color is red, I get this, and this is actually the picture on the cover of the book. And so that you can see just very easily how you can change those colors. I did also have some changes on the the values over here. It would be x-axis. So x tick number was equal to 6, and because I saw that I had the choice of starting at that -2.5, then it started from there, or -1 rather, and it started from there and picked those 6 points. So you can experiment with what you like on those. The next thing we look at is a contour. You can see that kind of peeking in here. So sometimes when we see an image such as this, if you come across, say at height 10, and if you say at height 10, if there, you could somehow bring across and cut through this, what does that image look like at height 10? When you do a cut, there's going to be kind of a line there, and so you want to know the shape of that, and that's what we refer to as contour. So if you can imagine coming through here at various heights along the z-axis and sort of coming across and cutting through here. So when we see this thing starting to curl up down here, we may have some lines that are very close together as it flattens out here and here. It's possible that if you have a paraboloid shape, you can end up with say some concentric ellipses for contours. So that's the next part of this, is figuring out the contours. So we have a G contour. The grid we have, most recent works. You can either have it produce a legend or not. I chose the number of levels for contours in here. This is fairly consistent with the values on my z-axis. There's a number of levels option you can use instead, and so we can experiment with that. And here's a new option for us on the symbol statement. So when we go back to Proc G contour, we're back two-dimensionally and we're a symbol statement, not shapes. And so repeat says that we would want to repeat this 9 times for each of the 9 levels given here. And so that we can run this, and we'll do it a few different ways. Alright, those things at the top, we start seeing that are this is actually at the bottom. X is 2.5, so get our bearings here where we're at. So on the previous image, X is 2.5, we're right over here, and Y is running the whole range of Y. So that's what's going on here. So at a height of -20, we have this ellipse, partial ellipse here, and at -15. When we get to -10, then it's just a line across. It's this curve. So that the way you interpret these is that going for all of these, if the objective is to get the smallest value possible, it's going to occur somewhere in here. So you would choose values of the x variable and values of the y variable in this ellipse to get an observation less than -20. And so that if you wanted to say, well, I need an observation, I'd like the value of z to be in excess of 15, then it's the values of x from -2.5 to up to -1.2 or so, and then all across for any of the values of y, then we would end up with a response in excess of 15. So that's how you go about looking at contours or applying contours. It labeled each of the contours for me here, and that was because I requested the auto label option here, so that if I took that auto label option out, I'm going to demonstrate this using block comments. You also see it with a number of levels I've written there. So if we come back and we'd say turn this off, and then I run it again. Alright, it puts the legend out here. Now the problem is I chose black solid lines for everything, so I can't tell them apart. So that's one of the reasons I like auto label, is I don't have to come up with that many symbol statements. Because I said repeat that for all 9 of those. And the other thing I could do instead, say turn off the levels I've chosen and enable the number of levels. So I chose 9, have SAS pick these 11, and I'll turn off the colors so they're not all black. Okay, and I'll turn off the symbol as well. Let's reset the symbol statement. Alright. So I get different colors for the contours. It prints them here. You can see the values because I've chose a graph that has some symmetry about 0. It's why we see things symmetric about 0. In practice that doesn't happen. it becomes, for me, it's difficult to tell one color from the next sometimes. So that's why I favor this auto label option and then turn the legend off. That way it prints the value of the contour on the graph. And so we could come back to this part and say, okay, keep the legend, or yeah, keep the legend, but just look at the auto label and then try again, so that it prints the labels on there. So then I can match the colors and the values with what's going on up here as well. Typically whenever you look at these contours, unless there's a threshold value or an application value that's some fractional value, that would make sense, but it looks a little cleaner if those are whole numbers, similar to what I had chosen in the first iteration of the graph. So you can see what I'm doing here is that I could, if I want to try an option out, and you probably by this point in the course have seen some of that also, so you can kind of don't be afraid of making the errors, that you can just go ahead and turn options on and off, and it's like the worst thing that can happen is that it's a mistake and you go in and you take it out. Each of these images in the results viewer, you can see when the mouse hovers for a second that it pops up what this is. If you right click the image, you can save the picture as, and your image type is only a ping image. You can also change things, have a few more options. If you enable the ODS listing, that means that sends output here from our other procedures. Graphics output is a little different. SAS graph, notice now we have a new item here. It's a graph window here, and it just says graph 1, and I click on it and I see a different version of that contour plot, and so that whenever I see whatever's active in this window, I can right click and then I can look at filing those, and so I can export as image, and it's going to ask me what kind of image I want. And so I have all these file types in addition to ping images, and so that you can save these then one by one. There are some things using the ODS commands in Chapter 19 where you can do that a little more quickly. You'll have to check that out. But you can save any of these, so if you're typically working with JPEGs, that works. If you're going to bring an image that you produce using SASGraph software, as I think I've said before, I'd probably leave the titles off because you're going to move things around in your presentation or your report, and it's going to take on different figure numbers as you edit your document. So I would tend to probably just take the images and bring it into your presentation software for editing. I hope this makes you a little less afraid of trying graphs in SAS. Whenever I do an analysis for a person, very often the ODS graphic support from the procedures is adequate, but I oftentimes am looking at Gplot, Gchart, G3D, and Gcontour whenever I present results to people. As you get ready to make a presentation, a tabular arrangement of data is a lot of information for an audience to digest quickly, and so a picture is worth 1,000 words, as they say. So if you have a really good graphic, it can convey your result very quickly, and so there's some really slick ways in SAS that we can illustrate this. So here are just a few of them.